right now. And Alex, if anyone else joins us, please keep an eye on who's in the waiting room to let them in. So I just wanted to say thank you very much, Lisa, for inviting me today. Very much appreciated. Happy St. Patrick's Day to everybody today. It's a beautiful New England day outside, typically 40 degrees and rainy with overcast skies. So a true sense of St. Patrick's Day. I wanted to introduce myself. I'm Patrick Higgins. I'm the regional sales manager of New England with Eco Windows and Facades. Just to give you a little bit of a background of myself before we get started and how I came to present to your team today. I went to Fitchburg State. I've grown up and lived in Massachusetts my entire life. I did get my degree in industrial technology and concentration in construction management. Directly out of school, I went and learned a lot of key things about waterproofing, ventilated rain screen facade applications. I did a large stint where I was project manager of renovating windows. So got a lot of hands-on experience with different window providers, different window assemblies, renovation assemblies, and really got to take apart some assemblies and learn what assemblies work well and what don't work well. I recently became Passive House certified in 2015. So really, since 2015, I have not looked back and really been concentrating on high energy efficient buildings, or at least taking the applications and skills of the Passive House and implementing them in normal traditional design builds. Eco Windows and Facades, we're based in West Concord. We specialize in high performance windows and facades. Obviously, you can see our presentation today. And one unique bit about Eco Windows and Facades is we are more of a collaborative type approach with yourself and your clients. We do not represent a single source manufacturer. Instead, we represent many manufacturers, which allows us to listen to your needs and your thoughts and your clients' performance requirements for their structure, their building, and thus allowing us to be more of a collaborative type approach and pick a window that best works for your project, as opposed to trying to pressure a single source provider. We also offer installation as well. And as I had mentioned, we are based in Massachusetts. Our territory ranges up to the Canadian border, all the way down to the mid-Atlantic. And if the project is large enough, we'll travel anywhere within the world. So without further ado, I'm going to get started. Again, my name is Patrick. If anyone has a question, please speak out right away. Stop me. I will be happy to take your question. If I don't know the answer to your question, I will kindly ask your name so I can then get back in touch with you with the answer to your question. So don't be bashful. Okay, this is an AIA accredited class. I think that Lisa is going to be taking care of all your certifications. Is that correct, Lisa? Yes. Okay, good. All right.
Yes.
Perfect. All right, so today we're going to learn a couple of advantages of designing with a high performance window and door package. We're going to discuss and get into the nitty gritty of the components, how they influence comfort, energy, cost savings. And then we're going to finish up early with a couple of case studies, and we're going to take a look at some actual real life applications, some learning things that we had learned through our experience in installing and providing high performance products. A couple of examples of some high performance projects that we have worked on, couple local, couple outside. Getting into high performance, the most bottom basic threshold that we can speak to is performance. So many people will be very familiar with an R value. Traditionally, when we're speaking about windows, we will use the term a U value. A U value is essentially the same as an R value. It's just inversed. So traditionally, we're used to an R value that is very high, being highly efficient. Conversely, a U value being very, very low will be higher efficiency. So the higher the U value, the less thermal transmission and the better that your product is going to be. There is a very simple mechanism to translate U value into R value, or conversely, R value into U value. If you would like to stay after the class, we can do some math exercises. and I'd be happy to go through that with you. So getting into insulation, getting into energy efficiency, I like this example here. It's not a complete apples to apples comparison, but it gives you a really good sense of an idea of how an assembly that is almost identical to each other in this little red box here can actually perform slightly differently. So if we're looking at this red box here, you see this window on the left is a fixed unit with grids, and you have a operable unit with grids. The U value for the frame is exactly the same on both units, and the glazing unit is exactly the same. The argon gap is exactly the same. However, due to the change in the frame to glass ratio, as this one is an operable and this one is a fixed, this one has more frame value, this one has more glass value, the U value is actually slightly different, which indicates to me that the glass is the higher performing part of this high performance window package. So the more glass that you're going to have, actually the higher performing your window or door will be. Speaking more about glazing performance, I really like this slide because we're all in New England here, so we all have seen single pane. Hopefully we all are living in homes with double or possibly triple pane glazing, but it's a really neat application, and I find it very relatable to New England people here. In this particular instance, it is 14 degrees outside. There's a single pane of glass separating outside and inside. Right up against that piece of glass is about 29 degrees. Moving into a double pane piece of glass, still being 14 degrees outside, it's about 48 degrees. And then moving over to a triple pane piece of glass, still 14 degrees outside, and it's a nice and comfortable 64 degrees. This is assuming that your thermostat is set at 69 to 70 degrees inside. The reason that I bring this up is because using a high energy efficient performance or a high performing glass package not only saves on energy efficiency, but really allows the people and the occupants of your building to get the most out of their livable space. We've all been in a building where it's single pane glass or possibly poor performing double pane glass, and you'll have a couch or a seat right up next to the glass. Some of you may be working in an office setting where you have a single pane piece of glass or old wood, iron or steel windows, and you have that corner office and it's really cold, right? It's 14 degrees outside. You're in your office and you throw your sweatshirt on or you put your gloves on because it's so cold in that space. It's not a functional space at this point. You're cold, it's drafty, and it's not a very fun place to spend time. The main crux and the main reason to utilize a high performance window and door package is to take advantage of the entire structure and to be able to use the entire structure through and through. I say that the performance and lower energy cost is a byproduct of that. We want to be able to design buildings and design structures so we can A, blend the outside with the interior. I don't have to get into this too much, but we've all seen studies saying that the human psyche is affected by seeing nature and being of the out of doors. So trying to have a large glazing area not only impacts the person's psyche and their general well-being, but also now allowing them to take hold and to use this entire structure fully while feeling comfortable within this structure. And we can do this by adding 3 panes of glass. We will use multiple gasketing systems. We'll institute a sealed sash perimeter, and that gets us a very high energy efficient product. Adding all these small nuances together, and we'll talk more about this as we go through our presentation, will generally build into one full high performance building package. So as I had just mentioned, this is another example, still using this 14 degrees coefficient outside, 48 degrees inside. We're assuming that it's 70 degrees on your thermostat on your inside wall. A couple of things are going on in this slide. One, you have this guy who's really unhappy. He's got no body. His computer's melting, okay? 2 things are happening here. Anytime you're within a room that has a temperature difference of 6 degrees or greater within this one single room, you create what is called a convection loop. We all know that cold air sinks and warm air rises. So next to this piece of glass right here, where it's 14 degrees outside, a pretty typical New England winter day, the cold air is actually 48 degrees on the inside of this piece of glass. That cold air is falling quickly. It runs along the bottom of your floor, and as it runs to the center of the room, it starts to warm up. It starts warming and it starts rising. Your thermostat is about right here. Your thermostat is set at 70 degrees, and as this cold air warms, it's rising up. So now it's about 50, maybe 60, maybe 65 degrees. At this point, at 65 degrees, it has now reached your thermostat. Your thermostat is now calling for more heat because it's 65. It's calling it for a temperature of 65. And now it's adding more heat. As it adds more heat, you're exacerbating your convection loop. So it's now increasing this convection loop. Now, a convection loop isn't actually a big problem, but what it does is it reduces your comfortability. It makes you feel as though there's a draft in your room. So you reach for a blanket or you put on a long sleeve shirt. So again, it's not a very comfortable environment. So your convection loop is reducing your comfort. And because your thermostat is at 65 or set at 70 degrees and it sees that it's 65 degrees, you're now calling for more heat on a constant basis. As you call for more heat, you're exacerbating and increasing your convection loop. So it's continuously calling for more heat. So now your energy efficiency of your building is going much, much, much lower, because although it may be still overall 70 degrees in your room, your thermostat is calling for more heat because this cold air is being pulled through this convection loop. So same scenario, still 14 degrees outside, utilizing triple pane glazing, a much more comfortable 64 degrees right up next to this piece of glass. You have now reduced your convection loop. It is a much, much, much more environmentally friendly location of the building to live in. You are now reducing the convection loop, so you're holding to 70 degrees and you have a nice, still, and calm environment inside of your structure. So energy efficiency is improved and the comfortability in the living space is improved. A couple of examples of some high performance windows and doors. It is worth noting that these are very large window assemblies. So what I like to tell a lot of clients is that design what you love to design. Design with your heart, and then let the professionals figure out the equation of how to balance it and how to make it energy efficient. So we can still make a passive house or a very, very highly efficient building with utilizing floor to ceiling window walls. We don't have to use the old 70% building siding and 30% glazing. We can now blend that into 50-50 or even greater with a high performance window and door package. So your design basically is whatever you can think of, and the now implementation of a high performance window and door package can now make that design a reality without sacrificing efficiency or comfortability in your building. For those of you who are familiar with this picture, this is the Henry David Thoreau Society at Walden Pond in Concord. This is a project that we had provided Bill Allen Busman windows and doors for. It's worth noting that this project is a net zero project, and you can see that it is almost an entire glass window facade. Really exemplifies the fact that we don't have to sacrifice the design or glazing area for performance. And if any of you would like to walk this project with me, I'm very happy to, and we can talk more about it in person. Let me know. So I really like this picture here. This may be one of my favorites of this presentation, because this thermal image tells a tale of many tales. We'll speak to air infiltration at the very beginning, and then we'll dive into this a little bit more. So code allowance is looking for a 0.1 for an AW grade window. An air infiltration for a high performance tested window should usually be around a 0.01. It's about 10 times more what the code compliance is looking for. So imagine you're tenfold what the code is asking for, a very, very low amount of air infiltrating through these assemblies. Getting into this thermal image down here, I would like to invite and open up the floor to some participants to engage in the conversation. Which buildings here do you believe would have replaced windows or have old existing windows? Anyone want to step up to the plate right away?
The blue one has replacement windows.
That's right. So this one right here is a brownstone in New York, which we had replaced the windows on, and it is actually now a full certified passive house. This story is pictured very, very well and tells a great story because you can see that the blue is the cold. This is a cold winter day. You can see that this building right here is very cold for the thermal imager on the outside. You can see that the windows are very cold, just the same as the building envelope as well. This is telling me that the windows are performing either the same or greater than the envelope itself. Looking at the bottom floor, I can tell in this little picture right here and these little green spots that there's probably a small air infiltration here. So it's leaking a little bit of warm air. There's probably a couple of pinhole leaks at the head and the jamb of this window. And this being a door, it's a little bit more drafty than a window would be. So it's showing me that this is a very high energy efficient project. As I look down the street, I can look to my left and I can see that this window right here has definitely been replaced. And these windows over here may be either open or they have the top glazing pieces had been replaced of these double hungs, excuse me. I can look at this window right here and I can tell you that these are old single pane glass because they are glowing white hot. So it's showing us the difference between a triple pane, high energy efficient, a replacement window over here on the left and the right, and a single pane window assembly right here that is bleeding your energy. We can also tell that these windows right here have been replaced because these are probably more modern double pane glazing, and keeping to the historical needs of the location, this is probably single pane glazing where they're red or even white. So very interesting. A thermal image can tell a tale that may not be seen by the naked eye. We can locate air infiltration, we can see high performance windows versus single and double pane windows, and we can see replacement windows all within one picture. So pretty cool. So speaking to air infiltration, the traditional North American view of air infiltration is using silicones or sealants to seal your building envelope. Utilizing old school methods of Tyvek or Typar type building wraps, the future to high energy and high performance buildings and window fenestrations is using a vapor open, and this goes more to a passive house type thing, a vapor open peel and stick applied facade. That does a couple of things. One, that allows for very quick and easy quality control. Two, we've all seen and driven by construction sites where we see the Typar or the Tyvek or building wrap flapping in the breeze as it's tearing itself off the building. So it ensures it sticks and stays on that building and ensures that it has a nice airtight seal. And if we're utilizing a very high performance window and door package, we would generally prefer to use a taping system. A taping system has been used in Europe for 50 to 70 years with proven results. We know that in North America, we usually are using sealants where they typically tend to crack and have to be replaced within 15 to 20 years. That's the usual life expectancy of a sealant. So not just speaking to air infiltration, but also speaking to longevity of products that we choose in our building. So if we can use a tape product, very fast and easy to install, we can improve the air infiltration while also reducing overall maintenance costs of your structure. There are many different. Yes.
So if you're redoing the facade of an old house that has the old kind of board sheathing on it, that might,
Yes.
have gaps and so forth. Can you use a peel and stick product like that right over that, or what?
Absolutely.
Can.
Absolutely. It would be the best product to actually use. Not only is it going to stick and adhere to your building, your existing, like for instance, my building that I'm speaking to you from here, I have the old tongue and groove on my building, and that would be a perfect application. I would invite you to say that do the very best that you can to try to wipe it down free of dirt and debris so that will stick and hold much better. But most of these products will do a good job of holding on and staying in place as long as they're installed properly. And Alex, in 1 second. And part of installation of these self or peel and stick products is it has to be physically and manually applied. And what I mean by that is anything that uses adhesive has to have friction run over it to adhere the adhesion. So a Siga product or a Partel product or any of these high energy efficient products, they will actually supply you with a material, they call it a paddle, and you will rub it down to ensure that it makes a good mechanical fastening. Just putting it on the building and sticking it there will not hold it on the building. You actually have to physically go over each location to ensure that it gets a good mechanical seal. Yes, Alex.
So you're saying that this blue membrane is all adhesive?
That's correct. Yes, it is a self-applied. Yes, it is. This one right here is actually a Siga MyVest 500.
And how does that compare to those? I forget exactly what they're called, but it's like liquid applied.
Yes, so very similar to a liquid applied. They both are overall achieving the same goal, but personally, I prefer to have these peel and stick products because I can quality control them very easily and effectively. If you're using a liquid applied, there's tendencies, especially when there's uneven surfaces, to have pinhole gaps or small locations where there's not enough coverage and it doesn't perform to the proper amount. I believe that most liquid applied requires 3 to 5 millimeters of thickness. And if there's an inconsistency in the wall assembly, you can miss that and then it doesn't perform correctly.
It probably wouldn't also work very well in the situation that I was just describing with you, where you have that old board sheathing.
That's correct. So this is an example of that Siga product right here. I'm not sure if you can see it very well, but it does have a nice peel and stick application. And if we were in person, I could show you that it is actually quite sticky. This is a sample piece that I've had in my possession for about 5 years now. So you can tell that this is holding on to its stickiness.
How do you spell it?
It is Siga, S-I-G-A. But there's also many different types. There's Partel, and there's many others that are in. Henry Blueskin will also make a type product of that as well. Okay, ready to move on? Any other questions?
Thank you.
Okay. So moving on a little bit from air infiltration, still speaking to a high performance window and door package. As I had mentioned opening this presentation, my view of high performance window and doors isn't just an energy efficiency, but also the comfortability of living in the structure. We've all been outside and had road work in front of our building. We've all heard the jets or loud trucks rumble by our house. Part of having a high energy efficiency or a high performance window package is eliminating air infiltration. Now, we had just spoken to air tightness and air infiltration being very, very low in these high performance packages. Sound travels exceptionally well through air. If we can eliminate air infiltration, we can very much reduce ambient noise from outside. So having these very airtight assemblies is a double win, so to speak. Not only are you improving on your energy efficiency, your comfortability, and reducing sound transmission at the same time. There's two schools of thought when we're measuring sound. There's the STC value and there's an OITC value. They are both basically relaying the same exact information. Some say tomato, some say tomato. Two methods of measuring sound, but still relaying the same information. The higher the value of your STC or OITC will result in less sound infiltration. Now, the main difference between an STC value and an OITC value is where they start measuring sound infiltration. Your STC value is an old school rating system that was designed in the mid 60s to measure things such as radios or televisions or other type mechanical equipments. They start their measuring system at 125 hertz. The OITC system was designed to measure railroads, aircrafts, and lower type frequencies. That starts at around 80 hertz. So your OITC value is a little bit better at relaying the information than the STC value. It was designed specifically for building practices, where the STC value was designed more for just common use. So here in the New England type area, us being old school Yankees, you see that most of the time we're going to be calling for STC values. OITC value will be telling you the same thing. It's just more of a newer, a more accurate approach to the solution. Excuse me. So speaking to sound infiltration, and again, we're going to open this up to a little bit of a discussion here. Three main sources of sound infiltration that we have in the buildings that we live in and occupy today: air traffic, rail traffic, and highway traffic. I'm going to open it up. We'll go around the horn. I want everyone to give me an answer. I'm going to ask the question, which one of these three do you believe is the most difficult sound to abate? Meaning, what is the most difficult sound for us to eliminate in our structure? And I'm going to start with Alex because Alex is the one that I can see.
I'm going to say air,
Air. Okay. Do you have a reason?
just because it's really loud.
Perfect. I'm not grilling you. I'm just asking because we're going to have an open discussion about this. Chris.
Oh, God. He's going to go through every single person.
I'm going to go for highway because it's a lower decibel, it's lower frequency. But it's Christopher, please.
I'm sorry. Okay, Lisa, and we'll just do a couple more, or if anyone else wants to jump in.
Yeah, this is Dre. I
Okay.
would say it's the rail traffic because it's intermittent, so it'll come rumbling along. I've run into
Okay.
this before.
Okay. Anyone else want to chime in? Okay, so I always get the number one. I do a lot of presentations in Boston, so I always get someone that comes in and says rail traffic because rail is right next to my office, or I live right next to the tracks, and it always makes me laugh because it's like, okay. So the correct answer is the highway traffic. The highway traffic is the most difficult to abate because it has the lower frequency, the lowest frequency. Christopher, you hit the nail right on the head. Good job. Highway traffic also presents a bunch of logistical challenges due to the fact not only is it the very lowest decibel amount, but it also has very high frequencies as well. You have that 92 Toyota Corolla that hasn't changed the brakes in 180,000 miles, and it has that very high-pitched squeak when you press on the brakes. You also have horns that are very high-pitched or low-pitched if it's a very large 18-wheeler. You have, as Christopher had mentioned, you have very large trucks that will rumble down the road as well. Air traffic is actually the easiest of all three to abate because it is very consistent and it's very uniform in the sound and also the decibel rating. Rail traffic is very difficult to abate for two reasons. One, it is a very low frequency, as you can see in the slide. But two, it also has a uniqueness in the fact that it has structural borne sound, not just airborne sound. So as it rumbles down the tracks, as Drake had mentioned, it is vibrating the ground, which then gets reverberated back into the structure and then creates those sound waves inside of your conditioned space. So it's a little bit of an unfair question that I had asked, but you could understand where we're coming from here. So thank you for those that have participated. So how can we add value to a property? We can obviously look at something really simply and easily and say, well, let's reduce utility bills by utilizing a higher performing package. We can also maximize the living space by having a highly insulated window wall or window assembly, so you can maximize this entire structure for usage. We can eliminate that air infiltration by using a very airtight window and door package. And as we had just spoken to, we can keep those noise disruptions outside by eliminating air infiltration. So D, all of the above can give you value to your structure by simply utilizing a high performance package. Do I have any questions before we move on? Okay. A couple of examples of some high performance windows in this slide here. Oops. Come on. To achieve high energy efficiency, to achieve very low air infiltration, as you can see in this slide here, multiple gasketing systems will reduce airflow. In this particular instance here, you have 1, 2, 3, and I'm going to argue even 4 right here. EPDM rubber gaskets, eliminating air while also eliminating water infiltration. You may also notice that you can have double gasketing in your glazing pocket as well, or if you choose, you can also put sealant in this location as well. You may also notice that in this picture on the right-hand side here, we're going to eliminate thermal bridging or infiltration of unconditioned space. So by alternating the grain of the wood in different directions, makes it more difficult for ambient temperature to thermally transfer, through this profile simply by alternating wood grain. Or if you're using a aluminum structure, you can use a thermal break, and we can get to that a little bit later. So some of the components that we use to get this high energy efficient window and door package is going to be using a insulated glazing unit. We can use argon is the traditional method for insulating between the glass. Or if you're looking for something that is very, very high energy, we can also insert krypton, which is another noble gas that offers very high energy efficiency. I will note that a krypton insulation property is much higher, but also carries a much higher cost. It's a much more difficult natural material to manufacture. We're also going to utilize what is called a warm Swiss edge spacer bar. This eliminates thermal bridging, and thermal bridging is taking the ambient temperature from the exterior and allowing it to transfer into the interior. So you would imagine if you had a piece of aluminum, which we all know is very thermally efficient product, it will carry that cold or warm from the outside through the glass, through the spacer bar, through the glass, and into your structure. If you're using a warm Swiss edge spacer, it is composite material stuffed with desiccant. Desiccant is a material that you may find if you've purchased a new leather good, running sneakers, or some other materials that they don't want to have water. Desiccant will absorb water, and as it absorbs, it'll also expand. So in this particular instance here, you have a butyl surrounding this spacer bar, and if there is any air infiltration, there's always a small ambient amount of vapor in air, which will cause the desiccant to expand and thus will self-heal this window. So keeping a nicely sealed piece of IGU.
Patrick,
Yes, sir.
in terms of your filling gases, my experience some time back was that all these gases leak out after 5, 7, maybe 10 years. Do you still believe that's true, or have they changed the technology enough that it's no longer true?
Christopher, you just made the greatest intro into my next point that I was going to make. Now, I'm going to answer this and give me 2 minutes to answer your question, but it was a great segue into this. So traditionally in North America, we would see an insulated piece of glass, as you had mentioned, Christopher, fail in about 10 to 15 years. The reason that is because is traditionally in North America, we would build this piece of insulated glass right here. We would build that, completely seal it, drill a hole in the side of a sealed unit, insert your argon, and slap a patch on the side of it. Utilizing a high performance window and door package, 90% of this IGU is going to be manufactured in Europe, where they build this glass in an argon chamber. That eliminates a fail point that is being made in the manufacturing process where they have to drill a hole and put a patch on. So to Christopher's point, a lot of these high energy Windows components would fail in 10 to 15 years because that patch will eventually give way and allow for it to fail. Now, building on that, Christopher is right. Argon will find a way to escape the window assembly. That's just the way it is. We have never been able to date, we have not been able to build a completely airtight system that doesn't leak over its lifespan. So to Christopher's point, in hopefully 35 to 45 years, you get an extra 10 to 15 years out of utilizing this high performance glazing package. You will need to replace your IGUs. It's not to say that they won't function and hold air. It's to say that they probably won't function to the same degree as if they had argon inside the filling or the krypton inside. So that's a really great point that Christopher made, and I thank you for making it. So a couple of things that we can utilize: low E coatings. As I had mentioned, argon, krypton. We can use the low E coatings to either take advantage of a solar heat gain or to shade the solar heat gain, depending upon how you build and design your heating and cooling loads of your structure. We can do this with tempered glass, with laminated glass, or even a specialty glazing, which would be a privacy glazing type, where you could flip a switch, add energy, and you can actually dim or cloud your piece of glass. We do have that technology available. Utilizing a composite material for your spacer bar, not an aluminum or a stainless steel, although the stainless steel does perform a little bit better than the aluminum. But utilizing this high performance composite eliminates thermal bridging, and utilizing the desiccant with the butyl edge sealing reduces the amount of argon escaping from your window assembly. So we have multiple uses. Not only can we do double pane, we can do triple pane. In some cases, I can even do quadruple pane if you're looking for the hyper energy efficiency. We can also do triple pane with lamination. So if you're looking for impact resistance, ballistic resistance, or you're looking for something that may have, as I had mentioned, a privacy glass, we're able to provide that and implement that into a high efficient and a high performing window and glass package. So speaking to energy efficiency and getting high energy efficient products, we have a couple of things that we can do to increase energy efficiency. So although this example here is not an apples to apples example, because these are all 3 separate size windows, you may note that the U value for the frame is exactly the same. However, your U value for your glass can change dramatically based upon the thickness of your spacer bar. So when I'm saying this thickness of your spacer bar, this unit right here, if you make it wider, that allows for more argon or insulation to go into. And that argon gap, the wider that it is, the more insulation you can put in there and the higher efficient your window can be. So without sacrificing design, without sacrificing maybe a wood species or the type of the frame that you're hopeful to implement, you can play around with the spacing of the spacer bar, wider or narrower, to make a higher or lesser performing glass package. So a way that we can maintain design while also adding insulation value. So adding all of these components that we're speaking to, multiple gaskets, triple pane glass, high energy efficient and thermal bridge free spacer bars, adding all of these components together are going to give you one final product of a high energy, highly efficient window and door package. Now, these packages all can come in multiple different types of windows. You can have your tilt and turns here, your hoppers, your awnings, your casements, or in this particular instance here, you can get very fancy with some of these windows where you can have a flying or double French blind window. One sash can open, your second sash can open for a massive clear opening. And to tie it all together, as I had mentioned, there's some Henry Blueskin, a high energy efficient building wrap in the background. As I had spoken to earlier, we do not need to sacrifice design or the natural flow of your building to maintain a high performance building or window and door package. In this particular instance here, you may notice that this is a lift and slide 3-panel door. 2 panels are operable. This door is 10 feet tall. It's 21 feet wide. Each one of those panels is triple pane glass. They're about 1,000 pounds per sash. And now right there, Bart Betancourt is our principal and owner. He's moving 2,000 pounds of glass very easily for a massively wide and open area that will be the future of this outside living patio. So I stress this enough, or I don't want to stress it enough, that you can still design exactly how you want and still get an incredibly high performing building. Excuse me. Hardware is very unique in these high performance window and doors for 2 reasons. One, they have to support lots of weight. So stainless steel is almost always being used. And that also gives you the double edge that you can utilize these in an ocean environment without worrying about corrosion. 2, because we're looking for the very high air or very low air infiltration numbers, there is multiple points around this window that lock. So traditionally with a hung window, you will have 1, maybe 2 locking points at the meeting rail. With most of these tilt and turn windows, you will have upwards of 4 and up to about 12 places where the window will actually lock and engage. That is giving you a much more security while also compressing the gasketing that we had talked about earlier in the presentation around the entire perimeter of the window. That eliminates this air infiltration. That's how we get those really high energy efficient, those very high numbers. I know that Lisa had asked this question before we started this presentation, but it's worth noting that there's also utilizing a high energy performing product. You don't have to stress about window treatments or blinds at the interior. There's always a solution. We do offer these solutions as well. We can talk more about that after the AIA presentation, but it's worth noting that even utilizing a high performance window and door package, you can still have interior window and blind treatments that are very functional and with millions of different patterns and combinations. Screens in Massachusetts are required for all operable windows, and having a in-swing type product, there is a small bit of logistics that have to happen for a screen. So there's many options. You can have a hinge screen, you can have a snap-on screen from the exterior traditional type screen, or you can even have a rolling screen, which seems like it's a very popular usage currently. It gives a very high-end type look. It's only engaged when you need it, so you have a clear glass opening. I work with a lot of architects, and as a side note, they always ask me, what is the visual transmission for your screen? I want to look through glass. I don't like seeing screen. I don't like seeing screen either. The simple solution to that is using a rolling screen cartridge. It's a much higher end look. It can be automated if you want for very large floor to ceiling window and doors assemblies. And it allows you to look just through glass all the time, unless your window or door is open, and then you can engage that roller screen. We can also offer custom made screens as well for any application that you're looking for, matching wood grains with your screen, or you can opt for a traditional aluminum screen. Putting all these together, get you a really nice and beautiful final product, a high energy product, energy savings, comfortability, and a nice place to call home. Do I have any questions before I go into a couple of case studies? Okay,
Question.
go ahead.
A lot of times for renovations, I've heard that maybe a triple pane is not really worth the cost. I mean, what is your assessment of that? Is it,
I
is
think
it
that
better
that's an
suited? Sorry, is it better suited for areas where sound attenuation is more of a goal, or?
Okay, so that's a two-part question. So I'm going to answer the first part. The first part is that's a very old school methodology. The implication of newer technologies allows for less cost delta between double and triple pane glazing. Personally, I see about a 5% difference from double pane to triple pane. When I look at 5% over an entire window package, that is extremely nominal considering the amount of energy savings that you're going to get. I've done some personal case studies where I've seen it's about 5 years return on investment, 5 to 7 years. I see in my projects that I'm selling in my products is about the return on investment from going to double pane to triple pane. It really becomes a non-starter. And as I had mentioned earlier, it's not just about energy performance, it's about comfortability. So being comfortable in the space that you're living in, that's where it really makes a difference. And personally, I'm okay with giving the extra 5% down to be comfortable, to have my couch right next to a slider or a very large picture window and not have to worry about throwing a blanket on in the cold months. Your second part of your question was sound attenuation. When we're talking about sound attenuation, triple pane glass does not really move the needle all that much. If you want to have a very high sound reducing piece of glazing, you're going to alternate the thickness of your glazing. So you may have a 4 millimeter outbound, and you can have a 6 millimeter inbound and a 4 millimeter for your third piece of glass. Or you can do a 4 millimeter, 6, and an 8. Alternating thicknesses disrupts the peaks and the valleys of a sound wave. And if you're disrupting them by utilizing different thickness glass, you're essentially canceling and knocking the peaks off into the troughs, which will give you that nice straight line, which indicates very little sound. You can also, if you're getting into extremely high sound attenuating windows, you can sandwich an acoustical interlayer, very similar to your car window or your car windshield, where it has a safety layer in between. You can't actually see it, but you know it's there. That acoustical interlayer acts as a disruptor for those peaks and valleys of the sound waves. And that is not seen, but that essentially will take a 4 millimeter acoustical interlayer and sandwich them together with another 4. So that is really how you get those very high STC ratings. Your triple pane glass is only going to give you about 1 extra point. So it's not really moving the needle all that much.
Is that extra layer just lamination, or is lamination a separate thing you do for sound attenuation?
So for sound attenuation, you'll have a 4 millimeter, your acoustical interlayer, and another 4 millimeter piece of glass. Or as I had mentioned, you can alternate it into a 6 millimeter, and that's disrupting it even further. Did I answer your question, Lisa?
I'm guessing what I'm wondering is that for sound attenuation, we've done a layer of laminated glass.
Yes, you can put lamination in there and that will answer it. Yes.
So what is the acoustical interlayer made of?
That I can't answer. I'm sorry, I'm plugging in my computer. I don't know what the acoustical interlayer is made of, but what I can say is that it's clear. It doesn't impact the visual transmission of the glass. So again,
It's-
very similar to your car windshield.
And it's thin.
Very thin. It's maybe a half of a millimeter, extremely thin. So actually, I can show you right here. So in this picture right here, it's saying it's a laminated panel. That orange indicates the acoustical interlayer. Or if you're looking for safety glazing, that would be the safety interlayer. So you have these two pieces of glass that are sandwiched together. You have your spacer bar, your interior piece of glass, and then a sandwich piece of glass with another acoustical interlayer. That's going to get you those STC 40s, 42, 43, 45s. And that's pretty much the max that we know to date that we can manufacture for STC values.
Patrick, do you know what the cost differential is? Did you call it Henry Blue Wrap?
That is one of the wraps that you can utilize, and I'm not very well versed. Unfortunately, that's not my expertise. I'm sorry, I don't know the answer to that.
Okay, thanks.
But Lisa, if you want to get in touch with me after, I would be happy to introduce you to the New England rep of Henry Blueskin. He's actually
Henry
a personal friend
Blueskin,
of
that's what it's called. Okay, thank you.
mine. Okay. Any other questions? Okay, we're going to keep going. A couple of things that's very worth noting here. A high performance window and door package is only going to be as good as it's installed. If I like to draw the parallel between cars, I'm kind of a car guy. So if you're a person that doesn't know how to drive a car or a race car, having a Ferrari probably isn't going to really help you all that much. If you don't know how to drive a race car, there's no sense in owning a race car, right? So utilizing a high performance window is a two-part equation. Not only is it the product itself, but it's also the installation, ensuring that it's installed perfectly, as well as the attention to detail. We talked about, and Lisa brought up the point, we had talked about building wraps and types of materials that we use to waterproof and air infiltrate, reduce air infiltration. So ensuring that we don't have air infiltration is a two-part equation. Not only is it the performance of the product itself, but how we install it within the window cavity and the window or the wall assembly itself. So ensuring that we put the proper blocking in the proper locations or shims in the proper locations to ensure that this window is going to properly function through its lifespan. Or ensuring that we tape the rough opening and make a nice location for our back taping to be taped to. Also ensuring that we fasten it properly so it doesn't rack, or if it doesn't twist or it doesn't turn through its life expectancy. We always say, and especially here at Eco Windows and Facades, we always say the details make a good project a great project. So ensuring that we provide a high energy efficient window and door package, but also looking at the details, ensuring that we have the proper tapes, air barriers, and trims in the proper location in returns. All these things take a good project and make them into a great project. Utilizing a high energy installation method, making sure that we go through the details before we get out into the field. We don't want to have any surprises in the field, because then that results in construction delays, as well as, I don't know what I'm doing, let's just do something to make it done, okay? So going through the detailing process is something that we strive to make sure that we do the best possible product. As I had mentioned previously before, there's two schools of thought. You can use a caulking, such as this here, or you can use a taping method here. You can see that this is a water test where I can see daylight right here and I can see water infiltrating. Very difficult to see this very tiny little spot right here unless I'm on my hands and knees and looking at this that's actually 18 inches off the ground. So a little tiny pinhole doesn't seem like a lot, but if you have a bunch of them throughout your entire project, it now creates an issue on the inside. Or if you're using a nice tape, very easy to QC and to watch that in the field and say, I got it, it's sealed perfectly, I'm good to move on. Eliminating thermal bridging and silt details. Sill details are obviously the place where the most water infiltrates in a window assembly. So making sure that the details are proper, making sure that if you're going for a passive house, that you're eliminating your thermal bridging by utilizing a minimal thermal bridge material. This is actually cork. So using making a silt panning with your tapes here. So really details and preps, again, ensure that your window is airtight and watertight. You can also utilize sill panning details, such as you're seeing here, and a short cladding system. That allows for easier tape between your window and your facade, while also allowing water to drip off the face through the weeping system behind, and then a clear pathway out through this sill detail, or sill pan, excuse me. So again, it's all in the details. It's all how you detail it. It's all about how to mitigate water and keep water away from your structure. This is your final detail here of your sill pan. Again, as I had mentioned earlier, you can short clad your system to allow the integration of a sill pan. A great detail to use, full belts and suspenders. Utilizing weeps where they're required. Right here is a spot where you need to get water out of a fenestration. You're going to use a weep system as opposed to allowing it to drip out the bottom if it's a multi-light assembly. One way that you can get high energy efficiency is what we call is over insulation, or wrapping your insulation over your frame. So if you can take your insulation and put it on top of your frame, you're adding more value or insulation value to your thinnest assembly in your wall cavity, and you're actually improving your insulation. As the very first couple of slides that we had talked about, your glazing unit is actually higher performing than your frame unit. So if you can wrap the frame with insulation, you can go a long way for making a high performance structure. On-site coordination is a huge part of what we do. As I had mentioned, a great project is taken, or a good project is made by a great project is by the simple details. If you need ADA assisted opening system, you can have those. Making sure that you're coordinating with your general contractors to ensure that you have proper hardware or proper installation details of your window and door. I'm going to share you this example that we had worked on where there wasn't great coordination with the general contractor. This is a zero threshold door, and I'm going to show you what happens. So a fully compliant ADA door has to have zero threshold. Without having on-site coordination, the foundation was poured. And due to having the foundation poured, excuse me, they did not coordinate with us to understand that they needed to set this door into the foundation. Resulted in a day of jackhammering. But at the end of the day, it ended up being installed properly and it looked fine. But it just was a step that wasn't needed. So ensuring that we pay attention to the details, ensuring that there's close communication between architect, general contractor, and supplier means that we don't have to have these oopses, and we can ensure that we can get it right on the first time. Excuse me. I know that Lisa had asked me about this. A lot of people need to have a landmark approval or a historic approval, or I have a project that is National Park Service where it needs to be replicated exactly what we have seen in 1800s to today. And it's worth noting that we don't have to go back to the 1800s and use old technology to still keep the same look. Single pane glass, we don't have to use anymore. We can use triple pane glass and a super high energy efficient passive house structure while still maintaining the look of this historic residence. So as you can see here, these windows are almost identical to the same windows that were there. However, they are airtight, they reduce sound, and they are now a fully passive house structure without having to go back to those old school methods and methodologies that are inefficient and really, I'm just gonna leave it at that. The ability to replicate something that's old. This right here is a triple pane glass. It's a curved operable window. This is a project that we did in the Bronx that required a landmark approval, and it needed to maintain an operable sash. It needed to have curved glass, and the client wanted to have a passive house. They wanted the comfort, they wanted the energy efficiency, and it's worth noting that it can still be achieved. We don't have to go back to these old school methods when sacrificing performance to keep that historic look. Just some of the cuts that we did, we provided to the Historic Society to ensure that we got the muttons correctly, ensure that the radius was correct, and ensure that we maintained the sight lines. So I want to thank you all for your time today. I understand that time is the number one thing that we all have a finite amount of. It is the most invaluable thing, and I appreciate your time today. If you have any questions, I'm happy to take your questions right now, or please email me or reach out directly, and I'd be happy to assist you in any of your projects.
Thank you, Patrick.
Thank you, Patrick.
Thank you.
Where is your contact info?
My contact info is, let's see, I hope this is right. This is right. This is my contact info. So I am Patrick at ecowindowsandfacades.com. And you can reach me by cell at 508-944-6773. I'm very happy to come into your office. I'm a very hands-on type person. I hope that I did a good job presenting to you today because I prefer to always be in person. I like to have examples. I like to bring in and show and to touch and to feel. So if you would like to have a closer look at some of our samples, please reach out to me. I'm happy to come to you directly. If you have a project that is in mind that you think might be a good fit, again, I'm very happy to take a look at it. Please send me some details, and I'd be very happy to run just a budget pricing exercise, no strings attached, see if it works. If it does, great. If it doesn't, no worries. We'll catch you on the next one.
Thank you.
Full
A
question.
quick question, Patrick, are you also capable of making arch top, round top?
Yes.
So.
Yep. Arch
fixed-
tops, round tops, circular windows, angled windows are actually a specialty of ours.
And those are fixed, or can those also be operable?
In some cases, they can be operable. In most cases, if it's an arched or a round window, it does become fixed.
Okay.
It does create a litany of issues with hardware with an arch or a circle. Not to say that it can't be done, but in most cases, I would say they are fixed.
Okay.
Beth, do you have a question?
Yeah. So being in New England with a lot of older housing stock, a lot of people want double hung windows. I noticed you didn't show any or talk about any.
Yes.
Is that a thing with high performance windows or what?
Great question, Beth. Thank you for bringing that up. The double hung window is the most energy inefficient window that has ever been created. So it's virtually impossible to get a high performance window with a double hung. What I can do, and what I do in that specific instance, is I can simulate a hung window. So what we do is we'll put a fixed with an operable below it, or I could make the entire window operable and I can simulate a meeting rail between the two. And I do that very often to get the historical achievements or the historical accuracy, because as I had mentioned, you just can't get the high performance with the hung window. It has one, maybe two locking points at best. You can still put triple pane glass in it, but that's like putting a Band-Aid on a bullet wound. It doesn't really give you the high performance. It just gives you the illusion that it's being taken care of.
I've
Really-
also found that very cost inefficient, which maybe is what Alex was referring to. Like I've compared, you know, on a regular double hung window, like a Marvin or something.
Yep.
The cost doesn't make sense
Right.
for that,
Yep.
for that. So can you achieve the offset of the upper and lower windows, or
Yes.
no?
That's
Okay.
really how you give the illusion of it being a hung window.
So
Is it does
as
have
long
to
as
be offset.
the top sash is fixed, it could basically look like a double hung window.
Correct. Yes.
And how does, go ahead.
go ahead.
How does the cost of a window like that compare to a Marvin or a standard, more standard window?
Right. And so the answer to that is it's most likely going to be a little bit more expensive. If you're talking about like a Marvin Ultimate series, that's
Yeah.
where I start to get more competitive. And in some cases, I've actually beaten the Marvin Ultimate series. But if you look at this and you look at your Marvin or your Andersons, your Pellas, whatever, there's a lot more engineering in this. There's a lot more that goes into this. And comparatively speaking, you're getting more for what you pay for. And
Oh,
so
I'm
it's not
not-
a true apples to apples comparison.
Oh, sure. Yeah. I mean, I'm not approaching it from that point of view at all. I'm just saying, some of my clients aren't even a margin budget, so
Sure.
a Marvin budget. So, yeah. Okay.
If the clients are a Marvin Ultimate window client, then what window do you think should be compared with that you think is a better window?
Yes. So if you are the Marvin Ultimate client, I would start with this Bildow and Busman profile. This is a great profile and it offers unlimited customability.
And who manufactures it?
Bildow and Busman manufactures it. They are
Who does?
German-based. Bildow and Busman.
Bildow and
Bildow
Busman, thank you.
Yep. I lost my train of thought. It was, if you're a Marvin Ultimate Series budget point, I'm going to get pretty darn close. And I would invite you to do a pricing exercise. If there is a delta between the two, let's take a look at it.
And what's the
I'm sure-
difference in lead time between the Marvin Ultimate and this one?
Great point. So as of late, I have been gaining a lot of business. Thank you to Marvin Ultimate Series being about 28 weeks of lead time. I
Right.
think that the last time I checked, they were 32 and they just dropped back down to 28. I am 15 weeks from a signed
15
shop.
weeks.
I'm a 15 weeks from a signed shop to a product on your job site.
Where's that manufacturer?
This is manufactured in Poland and all engineering is done in Berlin, Germany.
Great.
And the other question I had was, in terms of the U factor or U value, well, so the building code is 0.3, right?
Yes.
So, and you were, so with a standard window that you're talking about,
Mhm.
is that down to 0.01?
So
that
I
you
can use
mentioned initially, or where is that?
So if you're looking to do a comparison of a standard window, I can utilize triple pane glass or double pane glass, excuse me. That offers a slight bit of cost savings. And I'm usually in the 0.27 to 0.26 area. I can get down to a 0.11 utilizing triple pane glass, the widest spacer bar, the most thermally broken wood species, adding a layer of foam insulation at the exterior on the, separating the cladding. And that gets me to that hyper, net zero type application. I mean, that's almost an R10 window. So
Okay.
really, the beauty of the product that I offer is its unlimited customability. Not only just design, but also your energy efficiency. Do you want just a standard? Fine, we can do that in double pane glass and just a standard configuration. Do you want the most hyper performing window package that is known to the existence of mankind? We can work to get there. It's just a question of what fits the budget and what is the need for your building performance.
Okay.
Thank you. That was really interesting.
Thank you.
Yeah, really.
Do we have any other questions?
Bye, everyone. Nice to see you.
Take care, Lisa.
Thank you.
All right, so just in closing, again, we're based out of West Concord, and not only do we offer multiple high performance window and door packages, but we also offer installation. We understand the level of the unknown to a general contractor is always the greatest obstacle to overcome. So having our ability to provide installation, or we also offer a quote a la carte type service where we can offer a team to come and install the field mold or the very complex windows, the standard punched openings your team can install, or at the very lowest, you can have our team come and just oversee and just say, hey, you guys are doing really great, or you might want to check this location here. So we offer that type service where we can do the full thing for you. We can offer a little bit of hand holding, or we can be very hands off and just come in and tell you you're doing a great job. So again, I would invite you to explore some of these higher performing packages. It may not be as scary as everyone thinks that it is. And part of this is the education based. And again, I thank you very much for your time. So explore it. Let's design with it, because one of the greatest advantages to using a high performance window package is its unparalleled ability to make custom openings, massively large openings. It's not unusual for us to do 80 square foot windows, 8 feet wide by 10 feet tall, or 22 foot lift and slide by 10 feet tall doors, really bringing the outside to the inside. That is offering the most paramount level of design for you being architects. So I would invite you to collaborate with me or our team, or hey, anyone that sells high performance windows. But what makes us special in the industry is our unparalleled willingness to work with you on a design to ensure that when we go to CD sets or we go to a GMP set, that we know what we have designed is going to work. We'll do proof of concepts. I have an architect on my staff, so he can help and assist with drawings, details, CAD files, integration of drawings, and sequencing of building materials. And as I had mentioned, I stressed a bunch of times, the details make a good project a great project. And that is where we shine, is helping your team with detailing, with proof of concept, mock-ups, whatever it takes to get it there. We are dedicated to doing so. We like to say that we're not the standard window providers that you're used to that will give you a proposal and tell you to call them when they're ready to buy. We want to be involved with the design process. We want to make sure that the detail, the installation is proper, because as I have mentioned, a high performance window is only as good as it's installed and only as good as it's detailed. So we're very willing to help. We're very willing to go out there and work on details. We do not advertise at all. We work by word of mouth and by really spreading the word through AIAs. So we let our product sell itself, and we work by word of mouth by doing a great job of what we do. We don't fully canvas the world like some other providers with advertising. It's really, we let ourselves advertise and our work advertise for us.
Thank you so much, Patrick.
Thank you.
All right, thank you for your time.
Very useful.
Thank you so
I
much.
know.
All right, take care.
Thanks, Patrick. Bye.
Bye.